Good day, dear panels. My name is Lakai with matrix number B0117101021 from 4B Camp Section 2. Today I will talk about my project title, which is Wheel Drive Particulate Robot Moving on the Incline Halfpipe. In this presentation, there are 7 contents. For the introduction, the word pipeline in my project title defined as a series of pipes connect to each other to form a system of pipes that use to transport the oil, gas, water, or any other liquids or gaseous form substance through a long distance. The pipeline may be made up of carbon steel, stainless steel, titanium, and polyvinyl chloride or known as PVC based on the substance that need to be transported. In each country, the pipeline must obey the rules and regulations that stated in the standards and codes. And this is the example of the standard and codes of practice for the piping. For the motivation part, the pipelines that are broken or failure will potentially cause significant consequences for both human and natural environments. The advanced science and technology must be implemented in oil and gas industry. The inspection process on the pipeline is hard or impossible for humans due to the narrow size of the pipeline. Hence, many research papers based on the development of pipeline inspection robot is done. But the pipeline inspection robot that develops by industry and research are different in terms of cost, proficiency, electronics, and test analysis. And there are pros and cons by using the pipeline inspection robot too. For the advantages, the impact inspection robot can inspect the internal condition of pipeline that cannot be done by human. The impact inspection robot that develops multiple locomotion can move in different spatial working places, such as bending and junction. There is no need to cut off or dig out the pipeline to inspect the condition of it. For the limitation, the pipeline inspection robot that using the cable will limit its inspection distance. By using the cable as communication, the drawback will happen due to the friction between the cable and pipe, and it will be easily stuck in the pipeline, especially at the bell-shaped pipe. In this chart, we can see that there are a total of 234 pipe systems for the impact inspection robot from year 1987 to 2015. And at year 2007 until 2015, we can see that the orange bar is more significant compared to another color of the bar. And the orange color bar indicates the wheel type in pipe inspection robot. And by seeing this, we can say that the wheel type in pipe inspection robot has a great potential to become a trend. For the problem statement, there are typical issues for the pipeline inspection robot nowadays. The first one is most of the pipeline inspection robot is controlled by manually. And the next is only certain type of the impact inspection robot can operate in high complexity of pipeline system. Complexity means the junction and the bending shape of the pipe. And for the next is the major problem for the impact inspection robot is wheel slippage due to the traction of wheel. And majority of the impact inspection robot cannot maneuver or move at high inclination angle of the pipe. And there are 3 objectives developed in this project, which is to design and fabricate an articulate wheel drive impact robot that are able to maneuver or move at certain incline angles on the half pipe. And the next is to experimentally test the prototype of the robot on the straight half pipe for its stability and controllability using different leg angles. And the third one is to analyze the stability and controllability of robot prototypes using different types of wheels. And the scope of project is diameter of straight half pipe is fixed to be 152 mm since this diameter is easily to be found on market, and the range of the incline angle of the pipe is set to be 0 to 45 degrees. And the limitation diameter of the robot prototype is between 120 mm to 150 mm. and the radius of curvature is 1.5 times of the nominal diameter of the vehicle units. And there are 4 normal wheels, omni wheels, and mechanical wheels with same diameter, which is 42 millimeters, is mounted on the prototype. And the leg angle of the robot can be expanded to 40 degrees, which controlled by 4 direct current stepper motors. And the gyroscope sensor is used to measure and sense the angle of inclination on the impact inspection robot to maintain its stability automatically. And the Bluetooth module as wireless communication is used to acquire the data on the impact inspection robot, such as angle of inclination. For the literature review, the history of the pipeline inspection robot is reviewed based on 3 types, which is external, internal, and articulated. For the locomotion is reviewed, and we can find out that there is gravity type, low press type, and essential type. And this is the breakdown structure that has been reviewed based on the journal in the hardware and software system. And there is 2 types of the mathematical control system can be found in the journals, which is PID controller and fuzzy logic controller. And in recent 10 years journals, there are 6 of them is chosen because it is most related to this project. And we can see that the allowable pipe diameter is different because the developed impact inspection robots are flexible to expand or retract according to the diameter of pipeline. And the next is majority of the author is using the microcontroller, but not single board microcontroller such as Arduino Uno and Arduino Micro. The next is there are different type of wheels that have been used by the authors, such as normal wheel, omni wheel, caterpillar track, and oriented wheel. And only 1 out of 6 journals is using the mathematical control system to improve the performance of the robot, such as PID controller. And this is the most significant one because all of the authors are developing a manual control impact inspection robot. Overall project development flowchart is developed in methodology part, and this is the flowchart. And in this flowchart, it can be divided into 2 parts, which the dotted red line is FYP1, is done in FYP1, and the blue solid line is done at FYP2. And for the final year project design, flowchart is developed, and this is the flowchart which shows how the robot prototype move or function. Now I will talk about the preliminary works. The MATLAB curve as shown is construct, and for the capital D is indicate diameter of vehicle unit, capital R is conventional radius, small d is nominal diameter of the pipe, and capital L is length of the vehicle units, and A is alpha, which is turning angle. And based on the Journal of Design of a Semi-Autonomous Modular Robotic Vehicle for Gas Pipeline Inspection, and this is the equation, 2 equations that needed to be used to find the nominal diameter of the pipe and length of the vehicle units. And the first equation is used to find the nominal diameter of the pipe, and the second one is used to find the length of the vehicle unit. And this is the result that calculate by using the MATLAB code, and this is the nominal diameter of the pipe that has been calculated. And in the scope, we has defined that the PVC pipe diameter must be 152 millimeters, So we need to find the 152 millimeters value that nearby in this table, and we can find out that the diameter of vehicle unit that we can get is between 120 and 150. But in the scope, we also have defined that the radius of curvature is 1.5 times of the diameter vehicle unit. So the first table we need to use. The length of the vehicle unit does not be discussed in this project because the straight half pipe is used, and the length of the vehicle unit can be used in future works or improvement. Component selection and 3D modeling. These are the electronic components that used to build out this prototype. And we can see that the operational voltage of 5 volt can be used for this board. And the buck converter is used to regulate a higher input voltage to 5 volt output voltage, which is stable. And the ULN 2003 driver board is used to control the movement of DC stepper motor. Same as the DC micro metal motor is controlled by the DC motor driver. And we can see that the DC motor driver is giving out a rating current of 0.8 ampere, which is suitable to use for the DC gear motor because the current at no load for the DC gear motor is 40 milliampere, and the stall current at 6 watt is 360 milliampere, and the stall current does not exceed the rating current, which means it will be not burning the DC motor driver. And this is the 3D modeling of the complete model or prototype. And in front is the front unit and the back is the rear unit, which both of them is connected by a universal joint. And the stepper motor and DC gear motor act as actuators, and these are the stepper motor driver used to control the movement of the stepper motor. And this is the Arduino Nano, which is the brain of the whole system, or to control the robots. And this is the Bluetooth module used to accept or receive the data. And at the bottom of the robot, there is DC motor driver, gyroscope sensor, and buck converter. And this is the top view of the prototype. The left one is the front unit, and the right one is the rear unit. And all of these diameters are measured in unit of millimeter. And this is the front view of the prototype. Same, the left one is the front unit and the right one is the rear unit. And we can see that the robot does not exist the diameter of 152 millimeters, which is the diameter of the PVC pipe we use. And for the side view, the upper one is the front unit and the below one is the rear unit. And for the maximum angle expansion for the robotics, this is the robot at the initial condition or original position. We can see that the leg angles of the robot view is 20 degrees. After expansion to max, it will become 60 degrees of leg angles. For the conclusion, I will talk about what is the next plan for the project to progress. The stress and thermal analysis are needed to be performed on the prototype by using the Fusion 360 software. The maximum and minimum stress and strain that can be withstood by the prototype can be determined. The chassis of robot prototype is needed to be fabricated by 3D printer due to its small size. And the material to print is polylactic acid, or known as PLA filament. The basic movement coding for the robot prototype is needed to be written first. If the movement coding is correct, the coding for another devices or electronic components such as Bluetooth module and the stepper motor can be start to be written. This flow can convenience the troubleshooting process. And that's all for my presentation. Thank you.